has become known nationally and internationally for her work at the interface of mathematics research and mathematics education, serving in top leadership roles in the international math societies, including a position as vice president of SIAM. In that role, she's written further books, including math modeling, computing, and communicating, and also a set of guidelines co-authored with others oriented towards both the mathematical scientists making career transitions and towards mathematics teachers seeking guidelines for how to introduce a creative and generative approach to mathematics into the classroom. I've got to say, something that came across to me from speaking with Rachel this morning is that by going back to the origins of what it means to learn to do mathematics and to do mathematical modeling, even with our youngest students, there are amazing opportunities for us as professional researchers, as professional students of mathematics at the graduate levels, to really learn again about what it is all about. Rachel, this morning, in talking about examples from working even with elementary schoolers, introduced ideas of abstract symbolic manipulation, and really in questioning about why it is that relationships among sets of objects have to be the way they are, and the imaginative ability to explore all the possible relationships that could be, which is really why we all got into this in the first place. So I think we have a really exciting lecture to look forward to that will really transcend the levels from the very young to the moderately old to whatever else we will experience in our careers, and really unify it with the joy of mathematical discovery that got us here in the first place. So this is a very deep lecture, I think, that we're about to enjoy. Thanks so much for coming up and sharing it with us.
Thank you so much for having me. I've had a wonderful day meeting with many, many different student groups and faculty, and thank you so much for hosting me here at UW, where my older girl graduated. So it's nice to be back here and enjoying your wonderful campus and community. So I'm going to talk to you today about mathematical modeling all the way from kindergarten to industry. And if you're here to hear a lot of mathematics, that is, we will explore a lot of mathematical topics, but they may be math topics you haven't thought about for a while, because we're going to be talking about them in the context of kindergarten. I work for the MAA. I'm the Deputy Executive Director, and we envision a society that values the power and beauty of mathematics and fully realizes its potential to promote human flourishing. And that is really what this work today will focus on, is a question about how can we do that? And how can we all take some responsibility in moving through society as representatives of our profession and helping people feel more connected to mathematics and how it might have potential to promote human flourishing. All right, so let's start with a question. Why is it socially acceptable, and you might use the caveat, particularly in the US, to hate mathematics? What do you think?
Football.
Say it again?
Football.
Football. Can you explain?
That's socially acceptable. It's the opposite of that.
Oh, football is the opposite of mathematics, and football is far more socially acceptable. Is that what you're saying? Okay, what else?
A lot of people have had negative experiences and kind of hit a wall at some point, and so there's this huge population that just has a bad vibe, and it's a common experience.
And I'm going to repeat what people say just so everyone can hear. So tell me if I get it wrong, but many people can tell you the moment where they hit the wall. They view that moment as a moment they did not overcome. It was a negative experience, and it lingers with them, that feeling of not succeeding, right, in their past.
It's a negative emotional flag.
A negative emotional flag. Yeah.
But that does not explain why others accept that. It's shared experience.
It's a huge number.
And it's a shared experience because it's maybe a majority of people have that perception. And we in this room may be very much in the minority, right? Of the people who, I bet all of you can tell me about a moment you hit the wall in math, but for some reason you didn't quit. Or take that as a sign that you didn't belong or shouldn't continue. In fact, maybe you continued because you liked that feeling of hitting a wall and then hitting it again, and hitting it again, and hitting it again, and sometimes with some help, and sometimes without some help, making it over the wall. Maybe that's what culturally we love. But maybe everyone doesn't share that love so much, or didn't have whatever factors we needed to make it over that wall to the next challenge, or around the wall to the next challenge. Yeah.
I might suggest that it's viewed as something that only some intelligent life forms or some intelligent people can do. So in hating it, you're just sort of grouping yourself with others as opposed to indicating that you're not able to participate in intellectual life overall, like you would if you said you hated to read.
Yeah, so in contrast to saying I can't read, which is something you don't hear people say a lot, right? Or I hate reading, which I have heard some people say, but you don't hear it as much. Maybe math is one of the things that we think only certain people can do, and most people can't. And therefore, by saying you hate it, you're just putting yourself in a group with a lot of people who think they can't do it, okay? So let's put that collection of ideas together and think about how we might, in our teaching, contribute to this, or could work towards reducing it. So this is something I've thought about a lot. Has anybody ever put a mark on a paper that might make someone feel a little negatively about what they put on that paper? I mean, imagine a little kid doing a drawing and bringing it to you and saying, look, I drew a dog. And then you're like, nope. Right? It's not how we respond to little kids' drawings. And when a little kid offers us, or even a big kid, or even your graduate student offers you some math, they tried something, right? They created something. And if you hand it back to them with these red marks, I'm starting to think that maybe they are like little cuts that people carry around forever, and they accumulate. Now, those of us who get the check marks, it's like the opposite. It's like a little wind beneath our wings. But if you get these a lot, for whatever reason, they may start to signify something. And I can't imagine saying like, oh, well, the dog didn't have a nose, therefore it didn't have a tail or whatever. It's not a dog. Not a dog, right? Or, you know. And I think that then people start, because we have this idea of math people or not math people, people decide to put them in a category or another based on how much of this happens, possibly. So I think it's worth thinking about. And even though I've been thinking about this and talking about it for 2 years, I still watch myself do this to myself the other day. I had a list of things and I was like, check. And I'm like, what are you doing to yourself? You know, so it's so ingrained as our way of responding to things, right? And I don't think we take it as hard, maybe, as some people experience it from us. All right, so now I have the best job as a math ambassador. I get to go all over the country and talk to people about mathematics. And even when I don't mean to be talking to people, like they just ask me what I do, and I say I work for the Mathematical Association of America, then guess what? I get to hear their math stories. Right? And you know how they start, but you might not know how they can end. So a lot of math stories start with the moment of hitting the wall, or that teacher that they just couldn't connect with, or that class that they just knew was the last one they were ever going to take. Or I'm just not a math person. But these are pictures, these are actually videos. These are stills from videos of a person serving me yogurt, the person I was trying to pick up my car from, the person I was on vacation with in Aruba, a teacher I worked with for a while, 2 Lyft drivers. And these were all conversations that started with, I'm not a math person, or I hate math, or I can't do math. And when I said, well, tell me about that, and they started telling me their story. And I just asked a simple question like, well, what was your biggest problem today that you solved? Or, you know, well, tell me how you think about that. How are you thinking about that? These stories all ended up with them telling me how mathematical they actually are. And to have a PhD mathematician say to them, yes, you are, That is an incredibly mathy way to think about things. Wow, you reasoned that out really well. And that was a quantitative, logical way of reasoning. And quantitative, logical reasoning is the foundation of mathematics. So this woman works as a hairdresser, and she said when the machines go down, she's the one who can calculate everything, including the tips, without the machines. She's like, I can do that, right? That's the kind of math I can do. This guy started with, I hate math. And I was like, well, tell me about that. And he's like, well, my girlfriend did the algebra and I did the geometry and blah, blah, blah. And I really hated math, blah, blah, blah. And I was like, okay, can I, and he was just wanted to talk. And so I was like, well, can I film you? Sure. And when I started filming him, he started telling me about all the math they have to do in their auto service business. And I was like, on film, can we get back to the part where you hate math? And he's like, oh, no, I just said that. I'm like, wait. You led with that. You know I'm a mathematician. You led with that. You led with I hate math. Can we talk about that? Oh no, let me tell you what we did yesterday. And he just, like half an hour of video about all the math in his business. So you see, people really actually want to heal from those wounds. And it doesn't take much of a conversation to do that. And so I've really made it a practice as I move through the world of healing people. So I sometimes think of myself as a math therapist because I have resting friend face. It means that, like, no matter where I am, the person next to me wants to talk to me, even if they're like, I've tried to put on my earbuds and look mean, but they're like, excuse me, I just have to ask you something. Okay, let's talk. But might as well, right? Because if you're a math ambassador, you have a lot of work to do. Okay, so here's how I think about education. I really would like us to think about how to help students gather mathematical tools in their pockets. Now, I happen to have stupid girl pants. And when you have stupid girl or woman pants, you actually don't even have pockets. You have fake pockets or you have pockets that are this deep. But let's imagine decent pockets, right? Like deep clothing pockets, like carpenter pockets. And when they gather the mathy tools in their pockets, what do we want people to be able to do? We want them to be able to move through the world. And whether they have an abstract problem or a concrete problem, we want every mathematical experience to be like more stuff in their pockets. And when they have a problem to solve, we want them to know which tool to pull out first. How many of our textbooks are constructed that way? In general, if you're in chapter whatever, you know from the top of the page and the title of the chapter what tool it is you're supposed to use. And then you do, right, a mind-numbing sometimes number of that problem, right, of that, using exactly that tool. But we don't get to the point where someone can say, of all the tools I might use, maybe there's 3 possible tools, or maybe there's 10 possible tools, and which ones should I choose and why? And in life, that's more how it is. You have a problem to solve. You're allowed to use whatever tool you want. No one's going to tell you which one to use it. That's the connection to industry. Industry needs people who come in with tools. They know when to use them. A lot of people in industry will say, I can hire lots of people who have taken calculus and who can perform calculus, but they cannot point to me in my business where we can find some calculus they can do. And that's a problem. And in your department, I think you're thinking very deeply about these things. I've talked to a lot of people today who are thinking incredibly deeply about teaching and learning. And I really believe that you have the capacity to think about how to do this with your students. I want to help students have the power to tackle open problems. And I really believe that some of that mathematical connection can happen through that feeling of, I didn't just solve a problem, but I actually knew what to do to get there. And if I tried a tool and it wasn't working, I knew how to recognize that it isn't working and try something else. What's the next best thing to try? All right, so now let's do some modeling. This is true. My flight tomorrow is at 8 a.m. What time should I leave to go to the airport? You may talk to anyone you want. Go.
Do we know where you're staying? Where's the good coffee?
Good questions. I do know where I'm staying. I'm staying at the Graduate. What was the question? Where's the good coffee? I have no idea, but you can tell me. Oh, okay, can I have your attention? So I have 2 gentlemen here in the front that are asking me some questions. I don't know what the rest of y'all are doing. Now, who's going to the airport? You. Me. Who's your client? Me. What's going to make it a good answer? If I'm happy. In general, in math classes, in math textbook problems, when you get a problem, the problem is posed, you get all the information you need to do the problem, the person says go, and you go work the problem, right? That's what we're all trained to do. Correct? This is an industrial problem. This problem has a client. This problem has a human on the other side. All answers are not equally good. As mathematicians, even when we know there's a client, sometimes we have a tendency to go off in a corner with our team and start constructing a solution that we think is really cool using our favorite tool. Remember I was talking about tools? Using whatever tool we learned most recently that we want to try out on this problem, right? And we can entirely forget that we could do a beautiful job of finding a solution that makes us happy, but if the client isn't happy, then when we bring it back to them, it will be unrecognizable to them. They'll be like, what is this? And I've seen that happen on year-long projects. Okay, so I got two questions. One was, do you know where you're staying? I'm staying at the Graduate, very cool. The other was, do you know where the good coffee was? And the answer was, I don't know, you tell me. And then the third question was, well, do you want to chill at the airport? Actually, I think that's a very good question. That question is getting at, how risk averse are you? I'm extremely risk averse. I love airports. I tend to like to have an hour because I write really well in airports, so I get a lot of writing done. I am extremely unhappy if at any minute on the way to the airport I think I will have less than an hour. Others of you will be unhappy if you have more than 15 minutes in the airport, right? You will feel like you have wasted your time, gotten there way too early, right? Anybody like that in the audience? Yeah, see, there's a few of you. You would not want the same answer as me, right? What other questions are relevant in this situation? How am I getting there? How can I afford to get there? What are my preferred modes of transportation? Which modes can I afford? What else? Am I checking a bag? Nope. Do I have TSA pre-check? What is my citizenship, I would say, is an important question. Am I traveling, nationally, internationally? Do you get the point? Like, you mostly, maybe in your mind, thought you could come up with a solution to this problem, but you really can't. And that is the power of an open problem. In fact, you could spend too much time. You could ask me so many questions that I would get annoyed or say as a client, I don't have time to answer all those questions. So you have to be careful to ask the most important questions. Because the client's not going to sit around all day and answer just all the questions, right? You have to decide which assumptions are the most important. Okay, so the moral of the story is not like, let's solve this problem, but if you're solving what I would think of as a modeling problem, it probably should be connected to a context. And that context should matter and impact the solution. Make sense? And therefore, depending on which aspects of the context you choose to attend to, or who you're trying to make happy, or who you're trying to serve, you'll get a different answer. And therefore, different of you might choose to ask me different questions and make different assumptions, and then could come up with multiple solutions to the same answer, all maybe within a range that would still keep me happy, right? You could have different answers and I could still be happy. Okay. So you might come up with an answer that's like 2 hours, right, before it goes. And while that's a number, it may not really be a mathematical modeling solution because you may have just picked a number and that's sort of not really using a mathematical tool. Does that make sense? So not all solutions are equally fabulous. And not all solutions are equally mathematical in nature, right? Make sense? I had a great experience where I asked two people at a hotel and they both Googled and their phones gave them different answers. And then they proceeded to have a big argument about like which Google Maps answer was right. I loved that, right? Because that showed that even if that was your approach, you may still have to decide what you're optimizing for. Okay, so can you see how that was an open problem? Any questions about in what sense that was an open problem? And we often say open-ended, but it was really open at the beginning, right? And open in the middle. Open at the beginning because you get to decide which information you're going to collect. Open in the middle because you decide what tools you want to use. And open at the end because you're going to end up with different solutions and have to justify that solution individually. So really open. What qualities would make the solution good? Well, we said, please me, but I think that's not all. So I really think that considering the qualities of a good solution is something that actually brings applied, people who may tend to think of themselves as more pure and applied together. I think that we're all mathematicians because we have some values in common. All right, so let's just take a minute. I don't want to linger too long here, but just to compare what might be some of the things that make a mathematical proof, a good solution to a problem, versus a mathematical model. So stop me if you don't agree. We're not going to argue here too long, but I'm just curious. All right, mathematical proof. Prove a mathematical statement true, okay? Mathematical model. Provide a useful, reliable, math-based suggestion. Now, mathematical proofs are based on axioms. Axioms are assumed to be true. Yeah? Models based on assumptions, assumed to be true. Proofs based on lemmas and theorems, those are true, right? They come from the axioms. You use logic, and mathematical models have to incorporate constraints and data, which tend to be your reality. Both have to be readable and concise and elegant and compelling. And these are qualities, I think, that are qualities of our community as mathematicians that we appreciate. Both can be used as a basis for further proofs or models, right? And so when we create these things, we want to create something that other people can build upon. And in both cases, the thing you create has to be accepted, right? In the case of a proof, everyone has to agree that your argument, right? We don't have a magic proof checker, right? Proof checkers are people, and people have to agree that the proof is sound. Similarly, the model has to be accepted by the client. Okay? And I believe that both can inspire new mathematical thinking, new mathematics. So in both of these cases, we have some contemporary concerns. In the case of proofs, the issue of transparency and verifiability is huge. We have proofs that are thousands of pages long. We have proofs that are very complicated and build on mathematics in multiple fields, where there are very few people who could verify all of these things. And we have very few reward structures that say, you took your whole life to create this proof, and now I'm going to reward you for spending your whole life to verify this person's proof. And in the end, perhaps say, yep, I think he was right. What are we going to give him for doing that work? Same issue in science. We have results that need to be re-verified, right? You say a drug works. It costs an incredible amount of money and time, labor, verification, right? Certification to do the work. You spent all this money. You're ready to make some money. You're going to do it again. The very same thing, but they're going to get to sell the drug, right? Your work is just to make sure they sell a drug that works, right, the way they say. We don't have reward systems for that. And if these things are relatively easy to verify, peer review, we sort of do. But if they're really difficult, we really don't. We really don't have a way to reward people. I think this is a huge issue. In modeling, we also have the issue that we're starting to realize that if you have data, that data got collected by someone, right? And sometimes biases of collection can be embedded in the data. And so then biases of assumptions can get embedded in a model. And so you always have to ask the question, who is the model set up to serve? And I don't think we have enough work in our community also to be able to certify a model as equitable for any definition of equitable, right? And so this is work that's being done by various groups interested in openness and transparency and community, but we need to do some work. All right, so just to pause for a minute, have you had chances as a student to really tackle truly open problems? Just raise your hand if you think, as a student, you really tackled an open problem. All right, so I'm seeing maybe 5%.
Like in research or a class?
In a class. Oh, are you retracting? Okay, so in a class, in your 12 years of grade school, a little bit, okay? But not, okay, and I worry about this, because what are you expected to do as a grad student? Solve an open problem. Identify sometimes and solve an open problem. Identify which tools it is that you might want to use, what you should be reading to solve the problem. I really worry that, why aren't we giving kids this same experience? All right, and how can we? So I leave this with your community because I think you as a department have opportunities to do this. The National Science Foundation gave 3 institutions some money to partner with elementary school teachers to ask this question. And Kira, will you raise your hand? So Kira's in the audience. She's one of your newest STEM librarians. She worked with me on this as an undergraduate at Harvey Mudd College. I just want to acknowledge that she's here. So happy you're here. Okay, so these teachers, we worked with them in the Pomona Unified School District. And I'm just going to show you a small slice of this work with a kindergarten teacher who's up in the corner, Robin Stankiewicz van der Zanden. The 2 of us worked with Stacy Brown, who is a math education PhD. I have a applied mathematics PhD, and I think it's really important that when we do education work, we partner with our mathematics education colleagues who bring disciplinary knowledge to what we do and help us frame what we do in the context of what has come before. All right, so Robin, here's what I learned by observing her classroom, and I'll start actually with one of her colleagues' classrooms. A few things I learned from hanging out in elementary grades. All right, first lesson. Teamwork is not always awesome. How many of you have ever hated teamwork in a class situation? Look around. Like this is, so we know that. How many of us have assigned teamwork in a class situation? Same number, right? So what's going on here? Well, I always thought it's good for you. I don't care if you don't like it, right? It's good for you. It'll make you strong, make you tough, make you a better communicator at work. Maybe you'll just hate it and then hate it forevermore at work. All right, so what happened, I was in a 5th grade class and there were these 2 boys and a girl and they were talking about a project, and they had to decide what they were going to do for the project. And the 2 little boys kept generating ideas, and no matter what they said, the girl said no. They'd be like, well, what if we do blah, blah, blah? No. What if we do blah, blah, blah? No. And she was way bigger than them, and they were not crossing her, right? And so nothing happened. And I thought, oh, this is not good. Like, we didn't set this up right. I don't know, I don't teach, I taught 5th grade long ago, but I haven't taught 5th grade recently, and I wasn't sure, like within the context, but I thought, oh, we've missed a step here. Like we have not given them what they need. So I really started thinking about teamwork in my own classrooms. I also started thinking about teamwork in the industry environment where we know that there are some cases where people are not treating each other very well, right? So you can see it in the news. People are starting to speak up about toxic work environments. And some of this has to do with the fact that you can't accomplish anything in industry not in a team, pretty much. So we got to do this. But we have all these opportunities when kids are coming up in school to structure teamwork well. I'll tell you a little bit later about what I did in one of my classes to try to improve this. Basically by making sure that no one was in a group with someone that they really, really didn't want to work with. Because in one of my classes, someone had a restraining order out against someone else in one of my classes, and and I thought to myself, but that's a pretty extreme situation. What about in my classes where something terrible happened between 2 people and I don't know about it, right? And it wasn't reported, but maybe they just had a terrible interaction, or maybe I don't know, right? I just don't know. So I need to give them an opt-out situation. Does that make sense? And so I found a nice way of composing groups that would allow them to let me know if there's just someone they couldn't work with, let me know who they really wanted to work with, and then I could compose groups where they were at least with one person they wanted to work with, and they didn't end up with anybody they really thought they couldn't work with. And the truth is, when you ask students who can you really not work with, it's not like they list the whole class, right? They just list, and they don't all list the same person. And to be honest, if someone gets listed a lot of times, it might be worth thinking about that a little bit. Like, what's going on? Is that person bullying or being bullied? Like, right? I think that student is at risk. If you're on a bunch of students' lists of I can't work with this person, something's not right. And it's worth some thinking. All right, so I did tell you the story. But once I did that, I felt really confident that I'd compose groups that had a good chance, right? And then there were other things I tried to do to facilitate that group work. All right, so the other thing I learned in kindergarten was about open apportionment problems and how Robin actually decided to give her students some problems that sparked mathematical thinking that was far beyond the kindergarten mathematics that you were trying to get at. And we were really surprised. Most of them involve proportional reasoning, something that we really struggle with at the middle school level. Okay, so let me show you. Here was a task. Robin's husband is named Pete. So they always heard about Mr. Pete, and she has two kids. Two of her kids, I guess she's just talking about one of them here, Faith. She has two little girls. But anyway, at this party, there'll be two adults, two big kids, two little kids. Cupcakes are regular size, chocolate frosting. How many cupcakes should Mr. Pete buy for the party? Now, the students drew their answers, but they also used a headset and recorded their thinking while they were drawing. So what we ended up with is not only the drawing, but also their reasoning. So I'll show you what they said. So this student said that two cupcakes are for Mr. Pete, two are for the big kids, two are for the little kids, and two are for the moms. And you see that representation? It's pretty great. And then they wrote 8 instead of their name. All right. This student said the little kids get 1 cupcake each. They're down there. The big kids get 2 cupcakes each, and the grown-ups get 3 cupcakes each. They didn't count them all up, so in some sense, they didn't do all of what they were asked to do, but notice that they ended up with 12 cupcakes, which was different from 8 cupcakes, and think about that proportional reasoning, right? It's not just a simple we say one-to-one correspondence. That's something you're trying to teach in kindergarten, one-to-one correspondence. This student did 1-to-1, 1-to-2, and 1-to-3 all in the same problem, appropriately. It's pretty cool. All right, so here's another task. This is a really standard story mouse count that shows up in a lot of kindergarten tasks, and because it's quantitative, it's shown up in a lot of math ed literature for kids. So Robin decided she wanted to try something new with an old story. Apologize for the story if this gets anybody upset. But the truth is there's a snake, and the snake is really hungry, and the snake is interested in eating mice. And so in this story, the snake collects mice in the jar, and the story is usually about counting, like, oh, there's 1 mouse in the jar, the snake's still hungry. 2 mice in the jar, the snake's still hungry. 3 mice in the jar, all the way to 10, at which point the snake gets distracted, the jar tips over, the mice run away, and all is happy in the end, except for the snake, who's especially hungry. Okay? Got it? All right. So the task here is snake's hungry, collecting mice, 5 in the jar, not enough. How many will be enough? And the Seesaw application that she was using would read the prompt to them. So they were working on this individually, just one student. They could play the prompt, read as many times as they wanted, and they had this, and then they could do the work. So they didn't need to be able to read to do this, but they'd been playing with the story for a while. So this student says, how much can he eat? He needs too much. But if he gets a big one, he doesn't need to get more. Do you see what that student did? All right, let me play this back for you. If it's a big mouse, you only need 1. If it's a little mouse, you need a lot. That's extremely sophisticated and not even so easy to write down, right? So they don't have the formal, mathematical symbolism to say that. And if you just looked at that picture, you'd be like, oh, 1 mouse, whatever, right? But that's the snake on the left, and that's the very big mouse, and that's enough. right? Also not a terribly greedy algorithm, right? Like just one more is enough. It's good. All right, so this was extremely surprising, and it came up again and again. Like we would ask, we're going to have cookies. You know, how many cookies do we need? And the students would say, do you like cookies? And then they would say, are you hungry? And again, like the typical cookie question is, you know, there's 40 people in the room and there's 80 cookies. How many cookies does each person get? And the answer is what? You know, 2 cookies per person? But the kids wouldn't say that. They would be like, oh, maybe we'll have enough for so-and-so's class, because right? Because we already have 40 cookies, and they can have 40, and then everybody can have cookies. I just love that. Okay? So we were getting answers we didn't expect from these little kids. I learned that the 5th graders, not so altruistic. Just saying. All right. But if we were teaching kids that mathematics isn't always about the greedy algorithm, how would that translate to industry when you're asking questions about apportionment, right? When you think about the food in the whole world, and we think about all sorts of apportionment, how might this impact all of our thinking if we weren't always told to take exactly what you have and divide it up amongst the people who are most obviously in front of you, right? So I think these things are worthwhile, and I think these kindergartners can teach us some lessons. All right. I mentioned in the airport problem that context matters. The kids get that. They brought their life experiences to a lot of modeling situations. I already explained the cookie problem, right? Where they were already thinking about, oh, well, teacher, are you hungry? Do you want to take some home to your kids? Should we bring some to the office? Should we bring some to, they're always thinking about who else they can share with. In this case, remember the cupcake problem? So this kid says, well, this is how many cupcakes we need, and we need 7. And so if you're just looking at this, you'd be like, well, they misread the problem. There's 2 adults, 2 big kids, and 2 little kids. Why are there 7 cupcakes? Right? But the kid explained, right, that when you throw a party, Auntie always shows up. It doesn't matter whether you invited her or not, right? So if you have 6 people coming to the party, you better have 7 cupcakes. It's very clever, right? And with older kids, when we got them to think about this, when we said, oh, you're going to have a party, how many tables should you have, how many chairs? And we said there were about 40 people coming to the party, we could not get them to not think about the number 40. We were like, well, you better have a couple extra chairs. No, the problem says 40. Right? But the kindergartners can relax those constraints. They can bring in the context. They can make an argument. And they can come up with a better solution than we could have ever imagined, plus kind of fun. All right. Yeah. So context matters. And again, many times when I've been working problems with students, it's easy for all of us to get wrapped up in the solution and forget about the client's context and not check back with the client often enough to make sure that the solution that we're providing is going to work for the client's context, which sometimes has constraints they forgot to tell us about or weren't thinking were important. And so it's incredibly important as mathematicians to not just get wrapped up in our own heads. And what I loved about this is that at the end, the kids said, we're getting smart. And I loved that we feeling. They did a lot of catch and release where they would work individually on a problem and then they would compare problems with each other. And they really felt like by sharing answers with each other, they were collectively getting smart. And so math isn't anymore about me, and I'm better than you, and stacking us all, and who does the best, and who gets it perfect, and who got all those red marks. But it's very constructive, right? What is the knowledge and the experience that we created together mathematically so that we are math doers all together and we start seeing math in the world around us? So I think there are many affordances of open problems, and I haven't even started talking about how empowering it was for these elementary school teachers who also didn't always feel like strong math doers to engage these problems where there could be multiple solutions, where they could use the tools that they felt most comfortable with and re-engage mathematics in ways that were incredibly meaningful to the extent that some of them were like, now I want to go back to school and study math some more, which is pretty awesome. Did I miss anything here? So I have a bunch of affordances of problems. Do you see any? Were you thinking there's others that I missed? Curious.
Affordances?
Yeah, affordances, meaning when you give an open problem, this is what your students get. So these are the opportunities you could think of that are provided when you have an open problem.
I'd argue that a big one is the positive emotional flag attached to the experience of doing math, because that's almost the most important thing they have in their life, is this feeling that math is safe.
Feeling that math is safe, a positive emotional flag, or fun.
And
Yeah.
if they've got that, that will get someone through a million other problems down the road. And if it's
Right.
not there, they're dead in the water.
Right, and maybe the gold standard for a math class is that a person wants to take another math class. Right? Electively even, right? And so, yeah, I agree. And so the interesting thing is that it's possible that you could pose an open problem and a person could still have a negative experience because their classmate, it's like the kids on, like the two boys and a girl that I talked about, right? Where the boys' ideas are just getting stomped on all the time. So I think it's very true. I think that these open problems have incredible potential for positive emotional flags, a potential for ownership of solutions that I think is really leading to that positivity. This idea that when you pick your mathematics, so I will add that, I love that. And I also think we have to attend to when it goes awry. And when maybe some of the experiences of the more open problem where there's more discretionary space, both for the teachers and for the students, more people interactions sometimes can be not so positive. And so it's our responsibility as educators to attend to that and make sure that we keep our learners facilitating them to move in ways that are constructive. Okay. I would also posit that when we talk to employers, this is what they're actually looking for, and this is what they're hoping the mathematics community and mathematics training will provide them. So they really want creative problem solvers, they want good communicators, they want appropriate commuting skills, they want people who can explain why things go wrong, when they do. We know we've got algorithms in use that we don't know. And I really believe that mathematicians have a piece of the puzzle, right? In providing, we care why, right? And so we need to be in that game talking about why things may go wrong when they do. We want people who can use their skills in context, flexibility and adaptability, learners and self-motivators. These are all qualities that I believe that we provide opportunities for in mathematics. I think if we provide more open problems, we can do even more of this. All right, so let me ask you, are you ready to advise students who want to go out and get a big career? I hear in this particular department that students do internships, correct? Not as a requirement, but what I heard, thank you faculty, is that if a student wants to do it, they get pretty encouraged to do it. It's an optional thing, but they don't feel like, oh, they have to sneak around, right? And sneak into an internship and they might make their advisor mad. So that's awesome. That's really great. I think most places I've been to, the faculty have not had industry experiences themselves, and they don't feel ready to advise their students. I hope that in the future, we have more people moving in and out of academia and industry, that it's a more flexible pipeline, so that we can have people going into industry, learning what's relevant, what's going on, what's needed, and then popping back into academia, and we kind of get a break from each of those environments because they each are so wonderful and stimulating in their own ways. I think the future may be headed there because as we have more faculty that I like to call vital faculty, visitors, instructors, TAs, adjuncts, and lecturers, these vital faculty who are teaching courses, they don't have necessarily permanent jobs. And when you don't have tenure, you might as well pop in and out of different kinds of experiences. And we do see people doing that. We see people popping in and out of instructor positions in industry and enjoying both of those. I think that the people with industry experience will have, they will be very sought after. They already are. Everybody's trying to hire a data scientist right now, whatever that is. Do you know what that is? You can tell me later. Okay, so we wrote this book and I passed it around at your SIAM student chapter meeting earlier to try to help. So if you don't want to have one of these, You can get them from AMS or SIAM, and we also created an interview card game to help you interview for jobs and talk to each other. So that's going to be out at joint math meetings, and we're really excited about it. When you do these open problems, you have a really good story to tell. Whether it's a story of triumph or trial and tribulation, when you go for an industry interview, you'll have a concrete job to tell. And this is what people are really looking for. They don't want to just have a list of your courses. They want to know what kinds of problems you've solved. They want to know how you approach a problem, right? And so again, providing our students with these problems can help. So now I work at the MAA, and I just wanted to very quickly say, here are some things that we can do to help you connect students. So raise your hand if you know about PIC Math. Wow. PIC Math is a program to teach faculty how to teach industrial mathematics courses. So you go in the summer for a week, you learn how to, I think you have something called Clinic here as well for graduate students, is that right? Or did in the past where you did a kind of an industrial problem? Yes, no, maybe? So this would be for undergraduates, teaching an undergraduate course with an industry sponsor, and the PIC Math program provides the support undergraduate faculty need to do that, okay? So send somebody to PIC Math from this department this summer and teach a course next spring. We have new money for the MAA sections to do career initiatives. Stat Prep helps two-year colleges get data science going. We have 2 data science workshops this summer. We have one at SAMC and one at ISIRM. SAMC is sort of a more beginning data science workshop. ISIRM is a more advanced data science workshop. These are only for faculty. MathFest 2020 this year is going to be partnered with SIAM's education activity groups. I'm super excited about that. And I don't know if you know about the National Academy's Data Science Roundtable, but there's amazing videos from several years of convenings of people at the cutting edge of data science education. So if you're interested in learning what's going on out there in various programs, this roundtable has a lot of resources on video. And the Big Math Network, all your grad students now have cards that show them how to get there, but the Big Math Network has blog stories about careers in industry and the mathematics that people did that they really love in their industry jobs. All right, finally, we have a math values blog, and one of your groups of graduate students is going to submit a blog. They said by New Year's on some of the work they've been doing in their math ed journal club, so I'm really excited about that. Looking at the IP guide, the MAA Instructional Practices Guide, and giving us some feedback about how that guide may be able to be augmented to better serve the population that you're serving here and the types of classes and structure of classes. So I'm really excited for that feedback from your grad students. Thank you. All right, so ask me later about any of these things. All right, now I just wanted to very briefly say, I told you how I started doing teamwork differently, right? Remember that? Keep people from having to partner with people that they really felt like they couldn't work with. I also decided that in the case of this DE's class, this was a first year, so freshman, frosh student differential equations class, and they learned about compartment models. I wanted them to be able to walk out in the world and say, oh, I see something out there that could be modeled as a compartment model. So I let them pick any context that they wanted, but they had to use a compartment model. So some people, for example, modeled Lyme disease or California wildfire spreading or the lions in the cafeteria. And they had to come up with the most simple way of modeling that and agree amongst the 4 students in the group. Once they had that common base model, they could solve it. They could solve it analytically or numerically, whatever they could do. So that was open. And then each team member had to add a layer of complexity individually to the model. The good thing about that is in a 4-person group, if someone got sick and dropped out of the class for whatever reason, it didn't affect the group. A lot of times what we hate about group work is that you feel like someone's pulling the weight unnecessarily. But in this case, you went from that common base model that sort of built the team to doing something individually. And then they came back together and decided which of those bells and whistles they would put together for their final model, which helped them explore linearity, nonlinearity, interactions between terms, those kinds of things. So in the case of the individual work, if it was a success, if they were like, oh yeah, my bell and whistle really worked, that was great. If they could show that it failed, that was also great. Right? So they weren't graded on whether their bell or whistle was successful. They were graded on their ability to communicate what that addition did to the model, right? And whether or not it added fidelity, and whether or not they were going to choose to put that in the final model. And they were the best presentations I'd ever seen. And sadly for me, that was my last semester teaching. But other people have tried this since then, and I encourage you to try some flavor of this and let me know how it goes. All right, so they had that combined model, and we didn't know what solution they were going to get. All right, so last thing, I mentioned at the beginning that I think of myself as a math ambassador and sometimes therapist. And the way that plays out, like I said, is out in the world. So here's an example where I was at a hotel and I was checking in. Why are you here? Oh, I'm here to work with elementary school teachers on math modeling. Oh, I hate math. Not a math person. I'm really scared of math. I've heard there's this new Common Core thing. I don't know what it is. Sounds awful. Why are you here doing that? And so I was like, oh, well, tell me, what's your biggest problem? Like I usually do. And they were saying, oh, and they started talking about how they were a new establishment. They had all kinds of problems. And then I said, of course, as I usually do, can I videotape you talking about that? And they were like, sure. Okay, so here's the video. Oops, no it isn't.
Wait, no, what did you just say?
I said that the carafes hold 10 mugs per carafe. So.
Oh, okay, so maybe we need to go over here and look at the carafe.
Well, and the other problem is that a lot of people use these takeout cups, and we haven't figured that out, and I think there's 2 mugs to every takeout cup. So we have a mixture of mugs and cups, and it's just...
The mugs are bigger or the cups are bigger?
The cups are bigger.
The cups are bigger. Oh, okay, can you show me your coffee cart?
And then some people come in here with their own mug, those travel mugs, and the next thing you know, this thing's empty. And so we miscalculated.
Awesome. Oh, so coffee is a... Yes, it does. It absolutely does. Thank you.
All right. The woman talking, she's the one that, so the first woman talking was like, well, I'm kind of mathy, like I kind of like math. This was the one who was like, I don't do math. Did you hear her? Well, I think there's 2 of these for every one of these. Proportional reasoning.
Kindergarten level though.
Not kindergarten level. Actually, I would say maybe, what would that be? That would be, elementary school for sure, but relevant to the context of her job, right? And I would say the proportional, like trying to have a line be like a y equals 2x, that's sort of elementary, right? Sort of beginning of middle school kind of stuff. So the amazing thing was, I was trying to interrupt her to make her not have to talk anymore. And did you see how she kept interrupting me? Well, like the cream matters, right? Like that desire, this is what I'm talking about when I say people who have felt shut down or cut by math have this incredible desire in them to heal that pain and be mathy. Can you see that in her? I hope that you can. And when this conversation ended, I said, well, how would it be if I brought a group of elementary school students here to help you solve your problem? And they said, you can do that, but only if you let us help.
That's cool.
So I just wanted to thank you for a wonderful day. If you're interested in more information on how to conduct instructional spaces where there's a lot of discretionary space with evidence-based practices, we have the Instructional Practices Guide. This is what your graduate students are gonna give me a blog post on that I'm really excited about. And at the bottom is guidelines for assessment and instruction in math modeling education, which is also free, where we try to really, all the way from kindergarten to undergraduate education, provide some sense of how to facilitate open problems. So all of those resources are free online. I've had a wonderful day. If we have any time left, I'm happy to answer questions, or I think there's a reception after. So thank you so much.